Okay, so next for our factors, you want to make sure you go ahead and write these vocabulary words down. So if you want to pause it and copy them, you can. So the first part, a factor, is a number that divides another number with no remainder. So 3 would be a factor of 12 because 12 divided by 3 equals 4, which is a whole number, so that would be a factor. The next one, prime. A prime number only has 2 factors, one in itself. So an example would be 5. 5 is a prime number because we can only divide 5 by 5 to get 1, or we can divide it by 1, which equals 5. And those are the only numbers we can divide 5 by where we get a whole number for our answer, where we don't get a fraction or a decimal. So then prime and composite, these are opposite of each other. So a prime only had 2 factors. A composite, that's going to have multiple factors. So it's going to have at least 3 or more. An example of a composite number would be 8 because 8 can be divided by 8. 8 can be divided by 4. And 8 can be divided by 2. And 8 can be divided by 1. So because it is divisible by itself, 4, 2, and 1, that makes it a composite number, whereas 5 could only be divided by 5 and 1, which made that prime. Some special cases, 1 and 0, those are not prime numbers. 1 is only divisible by 1, and then 0, we can technically divide 0 by anything because 0 split into any number of groups is going to be 0. So those are not considered prime numbers. Okay. And then something that we're going to do to help us find common factors are factor trees. And that's a diagram used to find prime factors of a number. And we are going to go over what that looks like on the next page. Okay. So the directions for this example, we are going to create a factor tree for the following numbers and then identify if they are prime or composite numbers. Okay. Just a list of a few prime numbers, so we have them on the top of our head. Let's list those out here. That would be 2, 3, 5, 7, 11, 13, and 17. Now, these are not all of the prime numbers, but it is a good start. We'll go to 19. Okay, so when we're doing factor trees, we are going to keep factoring until we get to prime numbers. So, for example, 32. We would need to think of 2 numbers that go into 32. Typically, when it's an even number, a lot of people will start by dividing it into 2 and then whatever it would be. So 2 times 16 would be 32. So we just factored it into 16 times 2. Now 2, you'll notice, is a prime number. So that means we are at the end of that branch and we are going to circle that number. 16 is not prime, so we are going to factor that further. And that's also even, so I'm going to factor it into 2 times 8. And I know 2 is prime, so I'm going to circle that. And then we're going to factor the 8. 8 can be factored into 2 and 4. 2 is prime again. 4, not prime, so we're going to factor that further into 2 and 2. And we know that 2's are prime. Okay, so we use this factor tree to get what is called the prime factors. So that means that if we took, let's see, we have 1, 2, 3, 4, 5. If we took 2 multiplied by itself 5 times, it is going to equal 32. And if we look, is this number prime or composite? Hopefully you're thinking composite because it had more than 2 factors, 1 in itself. So that makes it a composite number. The reason we're going over this is because it's going to be helpful when we start identifying the LCM. So if you can do a factor tree like this, you are going to be able to do your LCM. And then also next year in Algebra 1, it will help when you are working with radicals and square roots and stuff. So it is an important skill to know. All right, next, 17. If we look at our list, hopefully you see 17 on there. So that means the only factors are 1 and itself. And both of those are prime. So that means we are done with this factor tree. And you'll notice this one's a lot smaller than the previous one. And because it only has 1 in itself, our answer would be a prime number. Okay. Next, we have 56. Now, the first one, we divided by 2 the whole way through. This one, I'm going to do a little bit differently. I know that 56 could be factored into 8 and 7, because I know 8 times 7 is 56. And 7 is on our list of prime numbers, so we're going to circle that one. 8, however, is not prime, so we're going to go ahead and we are going to factor tree that one out. And I know 8 is 4 times 2. 2 is prime, 4 is not, so we will continue to factor that one to get 2 and 2. And now we have our prime factors. So 1, 2, 3, 4. That means 2 times 2 times 2 times 7 would give us 56. And all of these numbers on the left side are prime. So that's our goal of our factor tree, to get to those prime numbers. But if we look at 56 overall, that is not a prime number. That is composite because we had more than 2 factors at the end of our tree. The important thing is, once you branch off of a number, you are not going to use that number again. So if we look back at this example, 8 branched off into 4 and 2. So that means we are done with that number. We're not going to return to it because we broke it up into 4 and 2. And then the 4 got split up into 2 and 2, so that meant we are done with that number. The only numbers we're using are at the end of the branches, the ones that we have circled here. Okay, now we're going to move on to a challenge problem. So I want you to pause this one and see if you can create a factor tree for the terms below. Okay, so for this, we have a number and then we have our variables. So for variables, that is going to factor into x times, and y to the power of 3 means y multiplied by itself 3 times. So we're going to have 3 y's being multiplied here. With our variables, that is all you have to do for the factor tree part. And then our number part, we are going to do the same thing that we previously did on the last problem. So 2 numbers that multiply to 28 would be 4 and 7. 7 is prime, so I'm going to circle that one. 4 can be broken up into 2 and 2. And those are both prime, so I'm going to circle that one as well. Now that we're at the end of our factor tree, we can write our factors being multiplied together. So we would have 2 times 2 times 7 times, then we have all of our variables over here, x times y times y times y. All of those multiplied together would equal 28xy cubed. And this is just a challenge one, so if this one was kind of confusing, you can definitely ask questions about it, but it is not something that will be assessed on this test. Okay, now we're getting into the greatest common factor. The greatest common factor is abbreviated as GCF, and that is the largest. So LCM was the smallest. This one is now going to be the largest factor that 2 or more numbers have in common. And we are going to start off with the greatest common factor of 12 and 30. So with those, we are going to start off with our factor tree, one for each number. So if we look at our 12, right away, 6 times 2. I know that equals 12. Then we're going to do a factor tree for 6, 3 times 2. All of these are prime, so then we're at the bottom of our factor tree. So for this, we have 2 times 2 times 3, and those equal 12. Now we're going to save those numbers, and we're going to move over to the number 30. So 30, we are going to factor into a tree. I'm going to do 15 and 2. And 15, that could be factored into 3 and 5. All of these are prime, so we are at the end of our factor tree. So our factors for 30 would be 2 times 3 times 5. This is where the GCF comes in. So the GCF is the greatest common factor. To get that, you are going to multiply any common factors. So we made a list, and if we look between the list, there is a common factor of a 2, and there's a common factor of a 3. So that means we are going to take 2 times 3 to get our answer. So once you have a pair, it only goes into our greatest common factor one time. So because we had a pair of 2s, there was 1, 2, and there was a pair of 3, so we have 1, 3. And 2 times 3 is 6. That tells us our GCF here equals 6. Okay. Once you are here, and you have that done, we are going to move on to the next example. Okay. We are going to do a letter B together first. So we are finding the greatest common factor of 16 and 40. So if we start with 16, that can be factored into 2 and 8. 8 can be factored into 2 and 4. And 4 can be factored into 2 and 2. And all of these are now our prime numbers at the end. So we have 4 2s. So I'm going to list those out at the bottom. And we're going to come back to this after we find our factors of 40. Okay. And when you do your factor tree does not have to look the exact same as someone next to you. So if you wanted to do 4 and 4 when you first started this factor tree, that is just fine as well. Now let's look at 40. Right off the top of my head, I know 10 times 4 goes into 40. And if we look, 10 and 4, neither of those are prime. So we're going to branch off of both of these numbers. 10 would go into 5 and 2, and 4 would go into 2 and 2. And again, your factor tree doesn't have to look the same. So you could have broke this up into 20 and 2, and then 10 and 2, and 5 and 2. You would still get the same answer at the end. So now this list, we have 2, 2, 2, 5 for our factors. Now we're going to find our GCF. For our GCF, we multiply together any common factor they have. So if we look, they have the first 2 in common, so I'm going to write that one down on the bottom. Then they have another 2 in common, so I'm going to write that one down. Remember, we are multiplying these. And still looking, there is another 2 that they have in common, so we're going to multiply by 2 again. And then that is all they have in common. So they had 3 2s in both of these lists. So that means we're going to have 3 2s multiplied together for our GCF. And that is going to equal 2 times 2 is 4. 4 times 2 is 8. So our GCF of 16 and 40 equals 8. Okay. Now would be a great time if you want to pause and try these on your own to see how much you understand, and then just make sure you watch the video to get your answers to check if they are correct. Okay, so hopefully you have your answer for letter A. This one we had 21 and 42. 21 can be factored into 7 times 3, and both of those are prime numbers, and that would be the end of that list. So we have 3 and a 7. Then over on the right, I would factor 42. And again, you could have done this different than me. So there are multiple different ways to do a factor tree. You just want to make sure your list at the end is the same as my list. So for 42, you have 6 and 7. 7 is prime, so that branch is done. And then 6 can be factored into 2 and 3, both of which are prime, so we would stop there, making this list 2, 3, 7. Then we can find our GCF. To get the GCF, we're multiplying any common factors. If we look, both of these have a 3, so we're going to take 3, and then we're going to multiply it by our next common factor, 7. So we're going to have 3 times 7. That's all they had in common, so we're going to stop writing more numbers, and that will give us our common factor of 21. So on this, you want to make sure both of your lists are the same, and then your GCF, you would take 3 times 7 to get 21. So make sure you have that on your notes. All right, next, C. Again, you should have this answer for you. This one we have 27 to start with, and 27 I know can be split up into 9 and 3. 9 times 3 is 27. 3 is prime, so that branch is done, and then 9 can be split into 3 and 3. So this list we have 3, 3, 3. Then we can break apart 45. 45, there are a few different ways you could break this up. You could do 15 and 3, or you could do 9 and 5. Both will get you to the same answer at the end. I'm going to go with 15 and 3. 3 is prime, so that branch is done. And then 15 can go into 5 and 3. And both of those are also prime. So our final list is 3, 3, 5. Once you have your two lists, you want to make sure both of those are the same as here. You are going to find your GCF, where we're multiplying any common numbers that they have, or common factors. So they have the first 3 in common with each other. We'll write that down. And then they also have a second 3 in common. So we're going to put times 3. So our GCF here is going to be 3 times 3, or 9. Okay. If this is still confusing for you, make sure you are asking questions. This is where we are going to stop. You are going to do a worksheet, and then there will be another task after that for when you check in. Let me know if you have any questions.